welcome back. We're at the South Dakota School of Mines and Technology. This is homework 9 in our Thermodynamics 2 course. Number 5, homework 9 is on other vapor-liquid equilibrium. Number 5 is a colligative property problem. Okay. And this is more of a demonstration of how we can either depress freezing points or elevate boiling points. Okay, so decreasing a freezing point is a pretty straightforward formula. We derived it in class. Essentially, and it's not something that's to be memorized, but essentially it says that natural log of x1 is equal to, where, x1 is our main solvent. Okay. So x1 is our solvent. That's equal to the delta H of fusion over R 1 over T minus 1 over T melting. Okay. And if I look at the problem, it says ethylene glycol is used as an antifreeze to keep the water in the radiator of your car from freezing in the winter. Estimate the fraction of antifreeze by volume that you need to keep from freezing at minus 10 degrees Celsius for waters in this. Okay, now we're going to assume an ideal solution between these two, or at least ideal solution from a point of view of volume of mixing. Okay, and so from the xi we can back calculate the volume fraction. So let's just kind of worry about the xi component. We're not going to really worry about the volume fraction aspect of it. But that's more of a mass and energy balance concept. Okay, so I'm given delta heat of fusion. I'm going to assume that's constant. I know what R is. I know what T is. It's minus 10 degrees Celsius. And I know for water, T melting is normally 273 K. And I say K because we have to consider this thing in terms of Kelvin. So I have to make that minus 10 into Kelvin. That needs to go to 263. Well, if I know delta H, I know R, I know T, I know Tm, well, I can solve for what x1 is through simple math, and then get back how much mole fraction there is. I can get the densities for ethylene glycol and everything else to figure out the mole fraction of everything else.